In this lesson, I'm going to talk about connecting to a web service, a simple JSON web service using codename 1. Now, there's lots of ways to do web service communication, including a wizard that I'm not going to use in this particular case for many reasons, but mostly because I want to show the actual JSON connection, which is useful if you're connecting to any third-party solution. So it will work outside of Java, even if you're not doing full stack, and it's really easy to work with full stack with JSON anyway when you're using Java. So the value of the wizard isn't as huge as it was before Spring Boot and things like that existed. So I'm going to use just the plain JSON and web connection, and I'm not going to use any special tools like XPath and which we do have in the processing package, or any of the third-party libraries or libraries from other developers in codename 1, because I want to keep it very, very simple to the APIs that you'd use normally day to day. I might go deeper into some of these later on, but the basic APIs are actually pretty simple, so I'd like to focus on those. So the web service that we'll use, and you'd be familiar with that if you went through the Spring Boot video, just has this sort of curl syntax, which means essentially we're to add an element to the web service, and this is the web service that I'm going to attack first. We just use a put request that places that element into the item URL, and it responds by actually returning the actual item that was added, which would normally be the exact same JSON that we submitted plus an ID value, which is auto-incremented from the database with everything related to that. So that's a really simple web service, just a put request that includes the JSON within the body. So to do that, I'd like to have an item class. If you recall from that video, if you've seen it, the item class is it's a business object, and here I need to actually redo it in the client. In this case, it's not an entity because obviously I can't copy the database object locally. And it's also slightly different. I added a couple of methods to convert the item into a map structure, and the reason to and out of a map structure. And the reason I need that is so I can convert it to and from JSON using the JSON parser. Now, I chose to use a way that's very similar to the way I worked in the server. There's another way, and I'll discuss it a bit later with the properties API, but I won't demonstrate it at this time. You'll also notice I trimmed quite a lot of code here, including the constructors and the getters and the setters. They're all trimmed because I'm assuming they're trivial for everyone, and because I just didn't have space. I didn't want the fonts to be tiny and completely unreadable. To actually send an item or get an item, in this case send an item, I've added a server class, and in that server class I have variables for the URL and the owner, and within that server class I have several methods to send and respond and get items. So the first method to send an item, to put it, is add item sync, and notice the sync in the end because it's a synchronous method. That means it sends an item and waits to return the value, and that's why we have the return statement here. And this is really important. This is a blocking method. You'll call it, and then the thread that calls into that method will stop its execution until the method completes and returns the item value. That's a synchronous method. Now, normally synchronous calls are very bad on the UI thread. you don't want to do too much I/O on the UI thread or anything like that. So because the UI thread, the main thread of Codename 1, the one that handles the events, handles the painting, handles all of these things, and I'll talk about it extensively in the EDT lesson. That thread it must be protected from blocking normally, because if you block it for too long, and too long can be milliseconds literally, if you block it for too long, you might cause a delay in the painting, in the drawing, and the app will feel unresponsive and it would be a problem. So I'd highly recommend that you be careful with these things. But this particular case is fine, because here we use a built-in Codename 1 method that's blocking in a legal way. And there's a special loophole called invoke and block. And the trick for that is used by the add to queue and wait method that I call here. And that's legal. That will not block painting. It will not block the events from going on, and the application should still work completely fine. And I'll talk about it in the next slide. But that's why it's called sync. The other things you should notice here is the way we generate JSON. So the request I'm requesting the addition of an item. So as you saw in the previous slide, I added a toMap method to my item class. So I use that in order to convert the map object representation into a JSON string. And that literally generates a standard valid JSON string that matches the structure I would expect to receive in the server. So now the string JSON literally has that item request. Next, I'm creating a connection request object. In this particular case, I don't subclass it. Often we subclass it. In this case, in the sync calls, I often don't. And I just build it to the URL. In this case, the URL is just the local host, and I add the item extension, so the code would be more generic, essentially. Notice the last argument, it's true. That means that this is a post request. But notice that I'm using put as the setHTTP method below. The reason for connection request has two modes, post and get. It doesn't have put, delete, or any of those methods. You literally have to use the HTTP method entry below. And the reason for that difference is that post and get embed arguments in a very different way. Get adds them to the URL, to the end of the URL, and post places them in the body. So there's generally just two ways to add arguments to a URL in HTTP. And that's one of them is post and one of them is get. There's also multi-part and other complexities, but that's a very different subject. Basically, those are the two important ways to add entries. And everything falls into either one or the other. And normally get is obviously a get request. Put is similar to post in that regard. So I'm selecting that this would be a post request, and I'm setting it to put explicitly. So essentially put is a variance of post. That means it adds arguments in a similar way. Although in this particular case, it doesn't really matter because we're overriding the body. So it mostly matters because post accepts an output stream to write into, and get doesn't. So in this particular case, instead of using the output stream approach, we just use setRequestBody and just place the body of the request. Instead of adding arguments, we just have the JSON as the body of the request, and that's it. And that works rather nicely. Also set obviously the content type and everything related exactly like we do in the curl request. Now, after I do that, the next line after add to queue and wait actually results with a response. And at that point, I just parse the response, check that no exception was thrown when parsing, although most of that is redundant because the data is already fetched, so there won't be an IO exception, but I need to catch it because it's a checked exception. And that's it. I have a map that I can parse out of the JSON and generate an item from that. And that's relatively simple, not all that much to understand here. But let's dig a bit deeper into the sync versus async, because the next method we'll look into is an async method. So I implemented both of the methods in this class, the add and the put, the add and the get, sorry, with both async and sync versions. So you'll be able to see the differences in the implementation and get a feel to both approaches to the API. Now, that's the main reason I did that, but usually you'd pick one and go with it for most cases, for each API that you use, although you don't have to be consistent because most developers, and myself included, mix, and we use sync for this and we use async for that, and we use both when possible. And that's one of the advantages of Codename One, that we have the ability to do both. Most APIs don't have that flexibility and need to use usually async exclusively. Now, the sync API has mostly advantages in terms of fluidity. It's really easy to use, because when you have things like a transactional process, so for instance, if you need to request something from the server, and if the server answers X, then you need to proceed to stage 2, then you need to ask the user, and then the user answers something, and then you need to again request the server to do something based on the answer from the user, and then again the server responds something, and then again back and forth. So you have a process that's really easy to do stage by stage with ifs, dialog prompts, and things like that. In that case, sync works, it really simplifies a lot, because you can literally write code that goes top to bottom with ifs, and it's a really simple, very readable code. When you use async, everything is a callback. So your code starts leaping between methods, and every stage becomes a map to, okay, where's the next stage? The code's unreadable from top to bottom unless you, and even if you organize it, it becomes a mess very quickly. So sync is really intuitive for some specific use cases. It's much easier, especially when we do things like dialogues or things like that. They are synced exactly because of that. A dialogue by default blocks, and that makes it much simpler to do some basic things like are you sure is a great example of something. I'm asking the user something, I'm waiting for a response, and until I get the response, there's no point in the application moving forward. So using sync for things like that is really convenient. Unfortunately, sync does have its drawbacks. One of the drawbacks is that it's slightly slower, and in some cases it's usually not noticeable, but in some cases it might happen, especially when you have a sync API and then with a call and then another sync API call and then again, and at some point you even reach a limit because you can't nest them too deeply. And that's where things start getting kind of wonky when you use sync. Things sometimes behave very badly when you're using sync. So things like if a method call is blocking and you're nested in, for instance, if you're in a series of an event chain and you're blocking because the sync call, the event chain won't proceed. Now that's a bit of a heady discussion, so I'll leave it to the discussion on the EDT, but generally if you're having weird problems, try switching some of your sync calls to async calls and see if that works. but you should usually pick what's convenient and what's right in the particular case. It's hard to give an exact guideline here, other than very specific things. And I'll show you at least one point later on where sync doesn't make sense at all, and where we have to do async to move ahead. And I'll show that later on and highlight it. So the async version of the same method is a bit more complex. First of all, we have to subclass the connection request. With the sync version, we could have done it, but we didn't have to, because we could just rely on the read response working. Here, there is no way for us to know when read response will actually happen, so we must override it. Or use an action listener, which is effectively the same thing. We'd be binding a listener to a callback, and it would still be async, but it's roughly the same thing, so might as well subclass. So in this case, you'll notice that another interesting thing is that we don't catch IO exceptions suddenly. And the reason for that is that the callbacks of the connection request throw IO exception to begin with, and have a global error handling section within the network manager, where they handle all of these sort of things. So that's really convenient, because you don't need to deal with all of the error handling nuances and things like that. You can just rely on global code sort of solving and closing. We don't need to close the input even. You'll notice it isn't closed, or the output, because the connection request, again, the network manager handles that for you. It opens the streams, passes them to you, and then cleans up after you. So it's like an ideal housemate that does all of the dirty work for you. And in that respect, it's really, really convenient. No cleanup, none of that. But it is a bit more boilerplate, so it's a matter of choice, though. You'll notice there's a couple of other big things here. First of all, I'm placing the JSON within the build request body. I could have used the same code that I used before of setting the JSON through the method, but I prefer doing it this way for no real reason other than to show you how it can be done. Otherwise, if I'm subclassing, the difference isn't that big. So I use this approach. The JSON is generated, by the way, in the exact same way, so there is no difference there. And then the response from the server I read within read response. Now, technically, I could have done it. You'll notice there's a separation between read response and post response. Within read response, I have roughly the same code as I have in the sync method. Only in this particular case, it doesn't have the try catch or the close of the output stream, input stream, or anything like that, because it's all encapsulated. But you'll notice that the onSuccess callback is called from post response. Now, that method is a mistake that I made because I named it that way, and I've been hitting myself on the head over it for a while. It's unrelated to post. It's kind of confusing. It's unrelated to post. In this case, I meant post as in after the response. And I probably should have said response on EDT or something like that, which is what it actually is. I just didn't like that name, so I didn't use it, which was stupid. And in this particular case, this method is invoked after read response completes, but it's invoked on the event dispatch thread. That means that's the UI thread. The read response and the build request body happen on one of the network threads, and they occur there. And you essentially get, that's why this is actually slightly more efficient than the previous code, because all of this happens in a separate thread from the UI thread, so it isn't blocking the UI in any way whatsoever. The previous code didn't block the UI when it was reading the data, but then the parsing code happened on the UI thread, which might have caused a stutter if you do that too much. This code happens entirely off the UI in terms of parsing, because I also do the parsing within the read response section. So this is noticeably faster than, well, not noticeably actually. You know, if it's a large JSON, it would be noticeable than the previous one, both because it's async and because some of the functionality happens off the main thread. And the post response happens on the main thread, and it sends the result item back to whoever called this. You'll notice that the method returns void because it returns immediately. You'll invoke this method because it's asynchronous. It will return instantly and will not have the result at that point. So if you need to add the item and know that it was added, this isn't the method for you. The other method, when you add the item, you will know that the item was added because it will be returned to you, a new instance of it. In this method, you'll add the item and you won't yet know whether the item was added actually, or if network suddenly went out. And the way to use it is you need to use the onSuccess callback to do the logic of what is done when the item was added or failed to add. So that's hopefully more understandable. The next web service that we're going to map is a very similar one based on get, where we get the data for a specific owner. In this particular case, I used Chai, but I made it generic for any type of owner. So again, this is relatively simple stuff. We just make a request, get back JSON, and it's just a simple get request, and we'll again see the sync version of that and the async version of that. So the sync version of that, and again we're starting with sync, again very simple. We use a request this time, we pass false because it's a get request, and we don't need to set the request method because get is the default when we have a get request. So a connection request to the item URL, and that's it. Now the next line, and this is interesting, I could have just written item question mark plus owner, something like that, plus owner equals owner, and it would have worked actually for this particular owner, for instance. That would have worked. I don't really need the add argument, and I would have saved a line of code. So why use the add argument at all? Well, add argument encodes the data, and encodes the data in case the data uses an illegal character or something like that, then it will implicitly work. Also, if you suddenly decide to change this to a post request or something like that, then add argument will implicitly work as well, because you wouldn't be relying on the fact that the argument goes in the URL and not in the body. So using add argument makes your code more generic and more safe in terms of working with characters that aren't necessarily one of the standard characters you're allowed to use in the URL. So that's really useful. The next line again, JSON request and add to key and wait as usual. And this is pretty much the same boilerplate as we had before. In this case, we're just parsing an array of items and building it into place. So there's not all that much of a difference with the get items than there is with the add items, except for the basic end result. The async version is again similarly structured to that version. You'll notice that I need to store the item array, so we'll return it in the post response again. It's again not a big method and very similar in practically every way. Again, add argument is used instead of building the URL. This is very simple code, and I hope it makes sense to everyone. So in this section, I'm going to integrate it to the UI that we actually had in one of the previous lessons, where we showed a to-do list. So if we think about it, the list of items can actually be a list of shopping items. And I totally didn't plan that or even think about that. This is completely random. I'm just thinking about it right now. And that list of items, we can add an item to the shopping list and then list the items. So what luck. We've got the web service working, we've got the UI for that working, and now let's bind it all together. So the first thing we need is to add two members to the main class that we had in the UI. One of them is the owner variable, which represents the owner. Previously in the web service I used shy as the owner. In this case I'm just using owner, so it won't show all of the experiments I did in the database. And obviously create a server instance with the owner, and notice the server is just the class that includes the async and the sync methods that I showed you earlier. So it's just that, and I'll make the calls on top of those variables, and we'll see soon just this. So if you remember, there's a for loop that just added the set of shopping elements into the UI. Literally a for loop that iterated all over the UI, very similar to the one here, only it didn't include the item variables. It just went over strings without too many calculations or anything related to that. So in this case, I'm changing a couple of things. I'm looping over item objects, and if an item isn't deleted, I'll just add it, just like before, only one by one based on the item value. And that's relatively simple. Now you'll notice I'm using the async method, and you might recall that I said before that I'll highlight a point where this is essential, that I use async and not sync. Well, this is the case, and technically it's not 100% accurate. I could have used the sync method and wrapped it with a call serially, but that's kind of like not using sync at all, because essentially wrapping in a sync method in call serially sort of disables it as a sync. But in this particular case, I'm before the stage where the shopping list form is already shown. So we initially need to show the form before we actually start doing anything. And this is the very first form in the application. And we also want it to appear regardless. If you're before show form, you don't want to use a sync call because it will block the form from showing. And that's kind of an important thing. You want the UI to appear first, and then you can block the EDT. So this is a bad place to do a sync call. Sync call works best in action listeners and things like that. And in this particular case, it would essentially block the form from showing, and because this is the first form in the application, that would be really bad. So that's one place where you mustn't use sync. Now, the next thing is I want to add an actual new element, so I want to call the add method. The add method should work through the floating action button. And so far I didn't bind any action to it, so now I'm binding an action to it. And actually most of this is actually UI code and not so much web services, but it's still interesting. So I'm binding an action listener to the floating action button, the plus button there. And the first thing is I want to scroll to the top because I want to be at the top of the UI for doing that, and I want to stick a text field right there and start editing it, which is exactly what I do. I literally open the virtual keyboard and start editing the text field. And once the user completed editing, if he entered text, I remove the text field and I create a new checkbox with a separator and animate it into place. And then I call the async version of the method to add the new item with the owner and with everything related to that. Then when the callback is received, I notify the user that the item was added on the server. And this works really well and pops up a text entry where you can literally type in the new entry and it appears into place. You'll notice I used the async call. I could have used the sync call in this particular case. This is one of those cases where it almost doesn't matter. I used async mostly because I felt it fit here. But honestly, there's no reason to have gone one way or the other with this particular call. I wouldn't have got an advantage noticeable otherwise from one choice or another. And this is how it looks on a simulator. I didn't run it on the device for one simple reason, and that's because the server is on my local machine. So to connect to a server on your local machine from a phone is kind of painful. You need to discover the IP and the LAN and sort of make sure that you're connected to the LAN and do it that way. It's unpleasant, to say the least. So I chose to just do this in the simulator for now. And it still looks nice. So I did, this was relatively simple. I didn't go too deep into that because there's an infinite amount of depth we can go into. But if you want to go further, there's a lot that we can do to practice this. And if you want to warm yourself up and get something, some learning done, then at least think about how you would solve these missing functionalities, if not actually go ahead and implement them and see how it works. So the first one is to implement the check functionality. I didn't implement that because I didn't implement an edit feature. So one would need to build a web service for editing on the server to actually modify an item, and that would be the approach you take there. And obviously also listen to the events and do that. Communicate all of the states in the UI and update the server synchronously, asynchronously, you name it. Extra credit is if you actually do a delete as well, because there's a feature for delete there that I used as a flag and not as physically deleting, by the way, which is a very common practice because sometimes, you need history and things like that. But if you can implement delete as well, I would do it with a swipe, where you can actually swipe the entries to the side and have a trash can icon or something like that and delete entries. I'd be interested in knowing if any of you do that, actually that level. And super triple extra credit is if you port everything to use properties. Now, properties is the thing that I mentioned earlier as more advanced. Actually, it's simpler in some regards that I sort of skipped in this presentation, and I'll talk about them later, probably in the bootcamp itself. Properties allow you to essentially avoid getters and setters and just write more concise code. And one of the nice things about them is that they automatically export and import from JSON and structures like that without you having to write almost any code, and which is pretty nice, if I do say so myself. So if you have that extra energy to go into that, I'd be interested in if someone gets all the way to doing this with properties as well. That would probably be cool. So I hope this was educational, and don't forget to ask questions. Let me know how we're doing so I can tailor everything to include information that might be missing in these presentations. So I hope you understood how to use a JSON web service, how to build something like that, how to communicate with a service like we created the last time around. that you understand the difference between async and sync calls in the network manager. I'm sure you don't understand it completely without background on the EDT, which I will cover in a future lesson. And I hope you understand that add to queue and block doesn't disturb the UI thread. That means it's a legal way to block the UI thread, unlike normally illegal methods of doing that. And I hope you understand how to wire a remote call to the UI and essentially make it seamless. Thanks for watching. Again, I hope you enjoyed it and let me know what you think.